Let's see if I can finish this lecture here. So basically what we do next is we introduce translations. Translation by P. TPx is x plus P, and TQx is x plus Q. And so we had f of P equals to Q. And we're going to think of L as being the given differential of f at P. We're given that that is invertible, right? So the Jacobian, I assumed it's it's non-zero. It's more than non-zero, though. The standard matrix of DPF, DFP rather, is and sometimes I put the P before or after the F, sorry about that. But the Jacobian matrix is assumed to be non-zero. Indeed, it's invertible, and as such, we can define F tilde to be TQ inverse composed with F, composed with TP, composed with L inverse. And if you check it out, F tilde of 0 is all of this, which is, TQ inverse of F of TP of 0, but TP of 0 is P, so that gives us TQ inverse of F of P, which is TQ inverse of Q, but Q and TQ inverse is actually just like the inverse of these maps is just subtraction rather than addition. So TQ inverse of F of P, TQ inverse of Q is just equal to 0. So in short, F tilde of 0 is 0, which means our little lemma applies, because we can also show that dF tilde of 0 is the identity. So you probably should do that in your homework problem that I asked you to complete this proof, right? So part of completing the proof would be to actually prove, and prove is perhaps too strong a word, but use the chain rule together with the identity of F tilde to show that dF tilde of 0 is just the identity. And if you guys have trouble understanding what I'm asking, do come and ask me. I'll try to help make it make sense. So then, indeed, we can argue that F tilde is continuously differentiable on 0 at 0, near 0, on the basis of the given assumptions. And so for r sufficiently small, we can, make the differential of F tilde at x minus identity to be less than or equal to epsilon, which means our little lemma applies. And as such, we can obtain neighborhoods, let's say U tilde and V tilde of 0, as well as the bijection G tilde from V tilde to U tilde, which is differentiable at 0, and indeed a successive set of approximations for the inverse function G tilde, like such, and by the Banach's fixed point theorem, right, as given by the little lemma. And then the rest of the proof, I say, is routine. Basically, you can use this to get back to F and show that the conclusions of the theorem are true. Now, I want to show you a little picture here to understand better, like the F tilde maps. So what's going on here is just this. We're given, whoop, come on. Oh man. We're given the mapping F that maps from P to Q, right, here to here. And the thing is, we can look at the mapping TP composed with L inverse from here to here, and TQ goes from here to here. And so he defines F tilde by, let's see here, the first shall be last. So if I were, let me get a marker and try to do it. I can find a working marker over here. Anybody's guess. Let's see. All right. So let's see. If I can scooch I guess I had to zoom out a bit. So F tilde we can build like this. All right. So F tilde should be equal to, so the last thing that happens is TQ, but it goes the other way. So TQ inverse. And the thing before that was F. And then the thing before that was TP composed with L inverse. That is a mapping from Rn to Rn, and you can show that it indeed satisfies the conditions of the lemma that we just worked out. Let's see here. Let me just check my notes, make sure I've got the right formula. It would be embarrassing if it wasn't the right formula. Oh, here it is. F tilde was TQ inverse composed with F, composed with TP, composed with L. Yeah, that's what it was. So that's pretty much it. Like, and then I found this in Edward's book, so I guess I'll even show you the if I can find the book, the page that has the completion of the proof. Since I'm doing this, I might as well do that for you. But the proof is not, the page is not precisely, so like here's the, he uses tau instead of t. All right, he uses tau instead of t, and his little f instead of my big F. So we, so basically here's some of the arguments that you probably want to understand. But you don't have to follow this. Like, you could just think through it for yourself if you want. That would be fine by me. But I do think you need the chain rule, basically. And let's see over here. Let's see here. It's the top of this page. I'll get to it eventually. There we are. Yeah. So these are the arguments that are still needed to complete the proof, but some of these are redundant. He'll argue something twice, two different ways, just to like make sure everybody gets it. But anyway, yeah, that's it. So essentially, the rest of the proof is just to show that we can use the little lemma. And so here's that book, Advanced Calculus of Several Variables by C.H. Edwards, Jr. So yeah, anyway, sorry I went over time, but this argument has to be given in one day. I don't think you can split it up and maintain integrity of the argument. So have a good weekend, guys.